live? Yes. Okay. LinkedIn is stuck.
Gotta get on Twitch.
Yes.
Let me try something. LinkedIn is stuck again. Worked. It's so irritating.
Probably because of the choppy connection on our side, if I had to guess.
Well, YouTube is up and running, so I will keep playing with LinkedIn. We're recording on Riverside, so I'm gonna take a screenshot to show them. But yeah, why don't we go ahead and get started, and hopefully LinkedIn catches up.
Okay, super. Let's jump in.
All right.
All right, here we go. Here we go. Yay. One time. Yeah, so if anyone's joining us, my name is Andrew Gillies, CTO here at Urban Machine, where we're making robots to reclaim lumber and help try to establish the circular economy for our built environment. As always, Jory Wisniewski, our marketing manager, co-piloting here with me. And today we have Aidan Barry back on the pod.
I'm back.
Back.
Couple month hiatus.
Yeah. We're gonna get into it today. We're gonna pick up at least part of the story from last time.
Mm-hmm.
So we did kind of a 2-episode series in the fall.
Yep.
Talking about the Z-axis actuator on our gantry picking robot.
Mm-hmm.
Z-axis is the one that's actually responsible for grabbing and ripping the nails out. And we're going through this exercise of mega upgrading that axis.
Mm-hmm.
But we weren't just upgrading the actuator itself, we're also completely upgrading the entire servo and control system across this entire machine. And that's the majority of what we'll talk about today. And in our previous system, we had different vendors supplying our little control modules. You could do a handful of servos off of those at a time. Very cost effective, very easy to set up, very user friendly. However, as we kind of get into this new tier performance that we're reaching, we're kind of getting outside the performance envelope of what we can get with that lower cost system.
Yeah, mainly controls performance.
Performance. Yeah.
Like
so
what can we monitor and how fast, and just this new setup will give us more options to see what's going on within the machine.
Yeah, absolutely.
Why is that? What about it gives you more options?
Basically, so the motors provide feedback to this new controls architecture through an encoder, through torque feedback, and we can basically, with the old system, we kind of have to pick and choose what we wanted to monitor. But with this new setup, we can monitor all the things we want to look at all at once. And so that'll give us more flexibility in performing various actions with this new machine.
Got it.
Yeah. The other thing it will allow us to do is do better coordination across axes. On the previous architecture, you have these individual controllers that can do 4 servos at a time, and you're kind of boxed into that, so you have to kind of think about these clusters of control across the system. Which means you need, if you want to coordinate actions across these different 4 servo clusters, you need to pop up a level to something like the computer,
right?
And you need to involve that in the control loop. And anytime you pop up a level, you're sacrificing some amount of performance because you have to have a communication layer.
Send information.
Yeah, exactly. With this new controller architecture, it's all centralized into a single controller that's much higher performance, that you can scale up to 64 axes on this new one. Which is a lot, way more than we need.
Yeah.
And then, maybe you can talk about some of the other nuance there, either cat, and all that.
Can I ask
Go
one
ahead.
question? You said way more than you need. Is that on purpose? Like way more than you need because you don't know what is going to come and you're leaving room for more, or?
Yeah, it's basically why we said that is for expansion. Like if we ever want to connect all of the machines to run off one controller, or if the machines grow in axes, we have the flexibility to move up to that level. We're not actually utilizing 64 axes right now, but at some point in the future we could creep up there.
Yeah. In some instances, you could manage an entire factory off of this single device.
Totally. And yeah, that's the nice thing about it, is you don't need to switch platforms again if you do end up, creeping up to like 20 or 30 axes. Yeah.
Okay.
And then, yeah, just getting back to Andrew's point. So this new controller that we're using is made by ACS Controls, and it's an EtherCAT master controller, which is what the industry, like the industrial robotics industry, is mostly moving towards in terms of its flexibility, ease of use, and like diverse like product offerings to surround the controller with, whether it's like motor drives, which we need, IO devices, which we need, safety devices. So there's a lot of flexibility to like grow our controls architecture in the directions that we want to by implementing the EtherCAT master.
Yeah. And the EtherCAT master and EtherCAT communication layer is one of several industrial communication protocols. There's several out there, but as Aidan said, everyone's kind of moving toward EtherCAT because it must be one of the best performing.
Yeah.
And it's also made open. So Beckhoff was the creator. Beckhoff is a ocean control, or just like a control supplier generally. And they created this protocol, but then they made it open access to the community. And I think there's a separate organization that administers the EtherCAT. So it's easy to adopt, and you're not locked into a specific vendor. Because of that, lots of vendors outside of Beckhoff have adopted it, like ACS, like other sensor manufacturers that we work with.
Mm-hmm.
And that's in contrast to some of these other communication protocols that have been locked into a specific manufacturer.
Yeah.
So if you decide to go with that, you're kind of stuck with them forever.
And it boxes you in in a variety of ways, but one of the main ways when you're like a small startup that's trying to move fast is lead times. So with Beckhoff, you can, as Andrew said, you can source different components from different vendors and still meet your schedule.
Yeah.
That's pretty cool.
Yeah.
I mean, it's a smart way.
Oh, Jory, we lost your audio for a second.
Oh.
We can't hear you right now.
Uh-oh. Oh, we're having all kinds of computer issues today, aren't we? Can you hear me now? No?
Might be like your microphone, maybe?
It's not popping up.
Yeah.
Can you hear me now?
No.
Yeah.
Okay. Yeah, absolutely. Yeah. So I think what we prepared today was we had our ACS control unit in,
mm-hmm.
and we've got a couple servos connected to it.
Yep.
And we thought the fun thing to do on the episode today would be something that we hadn't really done on this one time before, was do a live demo. So we were planning to actually walk into the shop and fire up this whole system, so you can see like in physical detail what's happening, what does it take to actually get this going, at least in a limited benchtop setup.
Mm-hmm.
So that's probably the best. I think that's like the most exciting. We should just get into it.
Yeah.
So I'm gonna attempt a little journey here. We'll take a quick walk through the shop and see if this could get going. We'll try to juggle all the various dongles I have going here. Aidan's gonna grab the camera.
We're going on an adventure.
And we're going on an adventure. So we'll walk into the shop here, and you'll see some of the other folks in progress. Heyo. Yeah. Okay. So here we are. And I can probably just run the camera. Okay, so yeah, here's Aidan. And Aidan's going to take you through the setup. You want to just like take us through some of the hardware and describe what we're looking at here, Aidan?
Yeah, totally. So this is the ACS controller that has built-in motor drives in it. So this is what we've been talking about for the beginning of the episode.
Okay.
And essentially, there's a couple things plugged into it. There's power here. There's power, auxiliary control power. There's safety power, and then we have 2 motors plugged in as well. So this is servo, and then this is also a bigger servo that we're going to use to power the Z actuator actually. So that will be, we'll do another episode on that thing running. So that'll be super exciting. But this is a big servo that's going to move our Z actuator.
Yeah. So in the servo world, this thing is absolutely huge.
Yeah.
Yeah.
And then there's Ethernet port that's plugged into my computer right now, and I'm hooked up to the drive through the ACS software. And basically, what I'm going to do is just create a little motion profile that we can run on the motors, and then we can show the motors running. Yeah, I think that'll be cool.
Yeah.
So basically, there's 2 axes we have hooked up. You can see them here. And I got to undo the e-stop here. Safety first. And then basically what happens is this is called a back and forth move. So we're going to move to point A, and then we're going to move to point B and back and forth, and it'll continue to do that after I enable the motion. And yeah, basically point A is set by number of revolutions. So we'll go 4 there, 4 or 10 back, or 4 there, and then 15 back, and then back and forth. And yeah, hopefully it'll be cool. And then you can also set your motion profile parameters here in terms of velocity, acceleration, deceleration, kill deceleration, and jerk. So yeah. And this system has a lot more functionality than this, but this is just a little bare bones demo for everyone. So I'm going to enable the motion, and Andrew's going to show you these things turning on. 1 second. There we go.
I see it.
So, yeah.
That's exciting. So
that's pretty much it. But here we see it spinning pretty slow. In reality, these things are going to be cranking a lot of power through them, which means fast and strong movements. Yeah.
Okay.
Yeah.
And explain that. Explain like what is it?
We still can't hear you, Jory.
We can see you. I'm going to stop the motion here just for safety. Hit the E-stop. And we're all back to safety.
Yeah. Okay. Let's walk back into the...
Yeah, let's walk back.
Walk back.
This is the computer. Grab this. Okay.
There's Demo Bird.
Yep.
Old Faithful.
There's a little podcast section right now.
Hear me?
Yeah, we still can't hear you. I can read your lips though.
That's impressive. Shoot. Now you guys are gone. Oh my god. You guys are gone. Andrew?
Oh,
You guys are gone.
interesting.
Can you see me?
We may not be able to turn the camera back on, Jory.
Maybe we should do a little
Yeah.
ramble and cut it.
Yeah. Yeah. Okay.
Yeah.
That's the demo. Yeah. So clearly some camera problems here, but yeah, it's pretty cool to see the whole setup in action. Yeah. So I think next time we have a couple more parts that we got to bring in for that actuator.
Mm-hmm.
So a couple dangling things, but that will be the next thing to fire that up and take a look at it.
And we'll show it all. We'll show it off. So
yeah.
That'll be super cool.
Yeah. Absolutely. Okay, well, we're going to cut off there. Sorry for the troubles of the mic, Jory, and camera on our side, but yeah, we'll get it dialed for next time.
All right.
Okay.
Sounds good. Bye.